Now it's time for our final presenter, Matt Graeber. He's given talks at a ton of different conferences, and he's going to be speaking about a couple of tracing facilities in event tracing for Windows.
What are we doing? Okay, all right, great. So again, my name is Matt Graeber. Either you're being very patient for Hugo coming up next, or you're just such diehard supporters of Windows tracing, in which case I'm really happy you're here. Otherwise, just be patient and bear with me. Okay, so a little bit of background. I came here, I don't know if it was last year or the year before, but Alex gave a great talk on Defender AV, and so that was just one of the Windows binaries that I had been looking into myself, and so I was appreciative of his talk. It was really detailed. And so as I was digging through Defender AV and, well, really any Windows binary, I started to notice a pattern. Also, a side story was lately I've been doing a lot of detection engineering work, and one thing that I do a lot when I'm building new detections is I will document blind spots and assumptions. So let's say you're building a detection off of something that you're pulling from the event log, right? Well, an assumption is that the event log itself hasn't been tampered with. So the event log, and I'll cover this in a little more detail in a little bit, the event log relies upon ETW under the hood to receive its events. So by taking an ETW trace session, which is the receiver of events, in the case of the event log, the application event log is just a special ETW trace session itself. If you remove the ETW providers, so the actual sources of the events, then you no longer receive events. And you can do this in a very granular fashion. So that's sort of the background of how I kind of tripped over this material. The stuff that the event log uses is a particular type of ETW. I'm going to be talking about the other two types of tracing, specifically WPP, which is the Windows preprocessor tracing, and TraceLogging. So WPP is like the older tracing mechanism, and TraceLogging is the newer one. A little bit about myself. It's my Twitter handle, @Manifestation. I'm a consultant at SpecterOps, and I really enjoy going down rabbit holes. This was one of them. All right, so some goals. I've already mentioned ETW, or event tracing for Windows, if you're not familiar with that. Again, this is the subsystem under the hood that the event log relies upon. And also, if you're going to be doing any dynamic analysis using the built-in tracing frameworks, you're going to have to rely upon ETW. Now, security vendors find ETW these days to be all the rage. But what I've found is that the security vendors that are out there that are consuming events, they're consuming manifest-based ETW. So this is like the classic ETW that is what's running under the hood for the event log. And there's a ton of events in there, don't get me wrong. But when we're talking about WPP and trace logging, manifest-based ETW and the event log in general, like if I had to ballpark, I'd say those data sources comprise not even 10% of all the events that could be theoretically consumed if you started to tap into these things. And another thing that I'd like for all of us to understand is one of the most important aspects, to me at least, in reverse engineering is that if I start recognizing patterns when I'm reversing a lot of code, in this case Microsoft binaries, you start to recognize patterns. And for the longest time, I can't really explain why, I just happened to overlook all the WPP and trace logging code. But since I was already doing other ETW related reversing, I started noticing these functions more and more. And so, as is the case typically, when you recognize those patterns, you start to dig in a little more deeply. And it's like, you go buy, let's say you buy like your first Subaru, like your first Subaru ever. You start driving on the road, and then you start to notice all the other Subarus on the road. It's the same case with like Windows APIs that you otherwise didn't pay attention before, but you start to see them all over the place once you start to dig into it. Also, with WPP and trace logging, they were designed for debugging, and so by the end of this, I'd really like for you to be able to take advantage of this to facilitate your dynamic analysis. So the use case that I'm going to be showing you is the Defender AV engine. So Defender AV engine, you have to be a protected process yourself if you want to be able to attach to it, if you want to do any sort of dynamic analysis. But because the Defender AV engine and so many other Windows binaries out there are so heavily instrumented, you can just start a WPP and TraceLogging event trace to have, in this case, the Defender AV engine just crap out so much information. Like literally almost every single function in the Defender AV engine is instrumented, and you can tap into it and pretty much in every case get all the arguments that were passed to every single function in that engine. And then lastly, we're going to talk about the ETW security model. By default, you shouldn't be able to tap into anyone's arbitrary events. So there's a good security model by default, but I'll show you a couple instances where that security model was subverted by Microsoft. Okay, so some key terminology. I've already mentioned manifest-based ETW. This is the primary driver for events that are fed into the event log. Now you can have other code as well that consumes these events. It doesn't have to just be the event log. But these are XML-based manifests, or it's serialized XML that's stored in a resource, in a binary that's then registered in the registry somewhere. So when you're consuming events in the event log automatically knows how to parse all of those events because there's a registration in the registry that points to the serialized XML, so that's why you don't have to do anything special to read all of the events that are populated and view all their properties and data types. So it's really kind of easy to work with this stuff. It's also designed such that any process can write to manifest-based ETW. So when there's this general manifest-based ETW registration, that means that's that ETW provider saying, hey, any process, you can go ahead and write events to me, okay? It's a very popular data source, as I mentioned, in security products. So just for example, the Microsoft-Windows-LDAP client ETW provider, I know of at least one endpoint security product that consumes Event ID 30, which captures all local LDAP queries. Now, something worth noting is that that Event ID 30 is not designed to be consumed by the event log because it doesn't have a specific attribute assigned to it, which is a channel attribute. And I'll show you an example of what that looks like in a little bit. Another one that doesn't have a specific event log entry, at least to my knowledge, is the AMSI, or the anti-malware scan interface event ID. So if you are an endpoint security vendor, I certainly hope you're consuming this because you're getting all events pushed to there is any AMSI aware binaries, so Windows Script Host, PowerShell, VBA, so on and so forth. All of those buffers can be captured if you were to tap into this. But again, this is all manifest-based ETW, and we're not going to dive in too deep, but I just want to make sure we cover our bases here and we know which one is which. So if you were to recover one of the manifest-based ETW schemas, it would look like this. So I used a tool from the SDK, I think, called PerfView. So it's a Microsoft utility. You can just feed PerfView an ETW provider name. In this case, I just gave it the Microsoft Windows Threat Intelligence provider ID, which is related to, well, I think theoretically any anti-malware vendor that has an anti-malware light service can consume this. So actually all these events specifically for this provider, the source are all in NTOS kernel. Okay. Now we're going to talk about WPP, so the Windows Software Trace Preprocessor. It's an older tracing mechanism. It really was exclusively designed for debugging and not for multiple processes to be writing events to. The tricky thing about this is that all event metadata is stripped from WPP traces. Now, with symbols and with the methodology that I'll try to articulate, it's not so terrible to recover these things, and I'm sure like all the IDA-Python masters out here with symbols could write some good scripts to automate the recovery of the WPP schemas. But I'm going to show you how to do that manually, and hopefully it won't be too painful. So this is what a WPP schema looks like. So this I got from the endis.sys public symbols. So you're not going to get these with all public symbols. It's just a select handful you'll get these from. So conveniently, we have endis.sys. So let's look at the first event schema up here. So the first thing that's highlighted is this is called the message GUID. So think of this in manifest-based E2W world. This is kind of like a keyword. So you can have a bunch of different events subscribe to a similar message GUID, and so those kind of serve to like group like events together. So like you see these three events here all have similar message GUIDs. The next thing to pay attention to is, in this case, MP. This is the event source. So let's pull this up. Event source would refer to this here. So if we're going to be looking in the event viewer, MP would surface here, okay? All right, the next thing to pay attention to is that box there. So that is the source, so the module and the source line. Because this came from public symbols, the actual source line was stripped, so that's why you see the 00 instead of an actual number. Next, an important one. This is the message number. This is equivalent to event ID. And when you save these traces to an EVTX, it is translated to an event ID. So message number, event ID, just slightly different terminology. Then you have the actual event message. And in this message, you'll notice there are two format strings. So present 0 is something that's not populated unless you run a trace with a tool called trace format or tracefmt.exe. That will print out the process ID, thread ID, and date time that the event occurred. And then the %10 is the first argument or the first field in that event. So just try to remember that if you're building these TMF files out yourself, all of the fields that are populated are going to start with that %10. And you have to supply, like if you want to actually display, say it's a string or a pointer or a uint, you have to supply the correct data type. So the box that's highlighted on the bottom, in the format string, it's %10p, which indicates it's a pointer, and then that p corresponds to the item pointer data type. Next, optionally, you can specify a logging level. You can provide any string that you want there, and also optionally, you can supply flags. So that is the TMF format in a nutshell, and this is what we're going to be building manually based on the Defender AV engine, which unfortunately doesn't supply a full TMF file for. Oh, and finally, the function name as well. Okay, all right, so the last tracing type is TraceLogging. I forget exactly when this was introduced, but it seemed to come to the surface around the Windows 8 era. The cool thing about TraceLogging is that all the event metadata is stored in the binary itself in a big binary blob, but there's a header file that you can read and you can write your own parser. I wrote one that's on GitHub. This, again, is designed for debugging. And it's intended so that only one binary ideally should be writing to those specific providers. Now, I don't know of any other endpoint security products, but I do know that Defender ATP does consume some of these trace logging providers. And I'll show you what some of those are. This is what that binary blob would look like. The way that you identify that trace logging metadata is present in a binary are the bytes ETW0. Everything that follows that, there's a well-defined binary file format consisting of event data and provider data. So that's all defined in the SDK in TraceLoggingProvider.h. It's a great reference. Terminology, I've already touched upon providers. A provider is, think of it like a channel through which events are written and consumed. So code can write events to providers, and then trace sessions, or a consumer of those events, can consume the events that were written to the provider. So the provider is the channel through which events are written and consumed. every ETW provider has a unique GUID. Many ETW providers also have a name associated with them. Well, specifically, manifest-based ETW and TraceLogging all have names associated with their providers. WPP, on the other hand, names are not supplied, but all of them have unique GUIDs. So that's going to be really important when we start building out our own manifest or event schema. All right, so again, trace sessions are the consumers of one or more ETW providers. You can consume events in real-time mode, and there's a bunch of APIs to do that consumption. You can also write raw event data to ETL files or event trace log files. Each event, okay, so the event log, as I mentioned, is every event log itself is its own special ETW trace session. So I already mentioned the application event log is an ETW trace session, and every sublog within the application event log, so think the PowerShell log, the WMI log, all that fancy stuff, all of those are just ETW providers that the application event log is subscribing to. Okay. So if you wanted to enumerate all of the existing or running trace sessions, you do logman query -ets. Let me show you an example of that here. Logman is a built-in utility in System 32. So ETS stands for Event Trace Session. So these are all of the running event trace sessions. All right. So we have a few here, and you'll see the event log application trace session is there, event log system, diatrack listener. Some of you may know what that is. That's related to telemetry. There are a ton of ETW providers in there. Microsoft does like to capture all the things. Now, if we wanted to look at a specific trace session in a little more detail, this is the output that we would see. So you would have some configuration details for the trace session, and what would follow would be all of the provider registrations. So there's a ton of provider registrations in the application event log. I'm just showing you one of them. So the first field is the name and the provider GUID. So as I mentioned, all these GUIDs are specific per ETW provider. This just happens to be the PowerShell one. The application event log subscribes to level FF. So it's just saying, hey, give me all the events. I want to consume them regardless of the verbosity of the message. Keywords any corresponds to, so there's a little bit of filtering that you can do in ETW, but it's not very powerful. So you can filter by event level or keyword. So a keyword is just a logical grouping of events. So in the case of PowerShell, this is a binary OR of 8, 0, 0, 0, and 1, all zeros. And Logman is nice enough to parse all that out for you to see what those numbers correspond to. So 1 corresponds to, I think, the admin channel, and 8 refers to the operational channel. And remember, when I say channel, I'm referring to groupings of ETW events that are designed to be consumed by the event log. Not all events, or most events actually won't have channels assigned to them. But the PowerShell log itself, many of its events are designed to be consumed by the event log. Properties, I've got a blog post I'll reference to later that covers the meaning of those, not super relevant at this point. Now, you can also get information about the provider registration itself. Now, this is manifest-based ETW, but I'm showing it to you because I want to show you the breakout of keywords and logging levels. So for the PowerShell provider, there are all these supported keywords. So for example, if PowerShell script blocks were going to be logged, those are logged in the, I believe, the run space keyword. And there's various other related events that have the same keyword. So you could filter on just the run space keywords if you wanted to, and on various logging levels. Okay, so the tooling that is available to you from Microsoft is the following. You've already seen Logman. Logman is like the workhorse generally for ETW at the command line. It's not very intuitive. It took me a long time to to really grok like how everything worked, but you can enumerate trace sessions, you can update and create trace sessions. So for example, like if you wanted to turn off PowerShell logging, you could just say, hey, application event log trace session, go ahead and remove that PowerShell provider for me, and then there won't be any events generated in that process that are PowerShell related because the event log has no way to receive events. So in my opinion, if you're an admin, this is a slightly cleaner way to tamper with the event log without generating like an event cleared event. Okay, WPR, not going to touch on that. It's kind of similar. It's like a more modern version of Logman. PowerShell has some decent commandlets to work with ETW in the event tracing management module. You can also do this through the GUI and the computer management MMC snap-in. Some useful tools in the SDK are TraceLog and trace format. We're going to be using trace format a little bit. And if you want to set up trace sessions, tamper with trace sessions, work with ETW providers, consume events, you have a bunch of APIs in ADVAPI 32. And then if you want to convert ETL files, which are just raw trace files, into something that's more usable, like EVTX, XML, CSV, you have a really handy tool called tracereport.exe. Okay, so let's dive into WPP. And again, our use case is going to be the Defender AV engine, mpengine.dll. So this is the sort of thing that I would trip over all the time, and previously had no idea what it was doing, but I just kind of ignored it and moved on just because it didn't seem like it was relevant to the core functionality of the binary that I was reversing. But I want to walk you through this in case this may be useful to you in the future. So when you load a Microsoft binary with symbols, this is the kind of output that you'll see. So let's dive into this specifically. So our first goal in wanting to start a WPP trace is we need the provider GUID. So we got to find that in the binary somewhere. So what we'll do is generally what you can do in user mode is you would jump to a call to register trace GUIDs. You can see that at the bottom there, and then identify cross-references to it. Usually there's not going to be more than like 2 cross-references to this because it's a pretty specialized API. And this is what is used to start a WPP ETW trace session. So you would work your way back and look at the control GUID parameter, look at the argument that's passed into it. And then up towards the top, you'll see what's passed into that argument is that WPP registration GUIDs global. So you double click on that, look at the cross-references, and then you would arrive to the WPP ETW GUID. So that's what you need to start a trace session that will capture these specific, in this case, Defender AV events. Okay, so make note of that. So now, at this point, we still don't really know what interesting events are available. So there's a couple ways that we could approach our methodology. One way could be to just capture everything, and that's what this is going to do here. We're just going to capture all WPP events, maybe do something interesting related to our research. Like, let's say I just right-clicked a file and did scan, and I'd want to see if there are any unique events around that time frame that fired. And then I could go back into code based on the output and identify where those events were traced. That's one way. Or since you have symbols in most cases, you could identify the functions that you're interested in and then jump to those specific message GUIDs and then start a trace that filters just those. Okay, so let's parse this out a little bit. So logman start, so we're going to start a trace session. We're going to call it Defender AV trace, like I'm supplying that. -P is the provider, so this corresponds to the one that we found in IDA. 0xFF is the logging level, so just give me all logging levels, I don't care, I want to capture everything. -ETS is going to start our trace session immediately after I hit enter. -mode 8000 refers to, that is local sequence numbers. So this is something you'll have to provide either 8,000 or 4,000, and I'll get into why that's the case in a little bit. And then -RT is going to be represent a real-time trace session. And then that'll start up, and then we can start our trace. So a tool that I use for like quick and dirty tracing is in the SDK trace format, -RT, give it the the trace session name, Defender AV trace, and then -display only displays the raw output of the events on the console. So pretty handy when you're just doing quick and dirty stuff. And then when you're done with all this, you just do logman stop to stop the trace. But note the -ETS, you have to provide that. Okay, so let's do a quick demo here. All right. So I'm just going to literally copy and paste what was in the slides here. Okay. So this is all events in real time coming from Defender AV. We still don't have any context as to what they mean, so it's now our job to proceed to the next step. So let's say I did something interesting, and then around that time that I did something interesting, an event came up. Or let's just say you wanted to get context around all the events. So one of the ones I found was like super common was message number 14 from this message GUID. So I would take that message GUID, find where it's referenced in code, and then see what the code does and start building out my TMF schema. Okay? So we're not there yet. So what I found was, because I had symbols, it was convenient, but you can also just do like a binary regex on that GUID and find it exactly in code really quickly where it's referenced. So that GUID is passed with some event data to the WPP SFS function. So again, conveniently, this was populated with symbols. What's noteworthy is WPP and SF will always be the same. So whenever this logging occurs, you'll always see that. And then the last letter in that function will correspond to the number of arguments and the data type of the arguments. So lowercase s refers to an ANSI string, and there's only one, so there's only one argument being passed to it. So a string is being traced to that specific message. Okay? We don't know what string yet. We haven't really reversed enough to get enough context, but I would like to start building out a schema that could at least dump those strings in real time. Some other noteworthy things here is you see there's 2 jumps. So this tracing will only occur if 2 checks pass. One, the WP global control structure is populated, which at the beginning of any code that supports WPP tracing, if it identifies that there is a trace session that wants to consume that provider GUID, then it will populate that structure. Another thing is it will check the flags. So when you're writing all this code in C or C++, you can specify specific flags. So this, the developer just happened to, this message is a flag 8. So if I wanted to do a slightly more granular trace, instead of doing FF for my logging level, I could just do 8. And that would constrain the events slightly. It's still going to be a deluge of events, though. Now, what you'll see next is I double-click WPP SFS, because I want to see what is actually going on within that tracing function. And what you'll see in all these functions is the trace message function is called. And really the most 2 things are noteworthy here. There's a message flags argument, and if you break out the numbers, or break out the flags, what you'll see is trace message sequence is specified. That means that you need, when you start your trace, you have to specify either hex 8000 or 4000 to do local or global sequence numbers. Can't tell you how much of a pain that was to figure out that that was a requirement. The other thing is that even without the _s symbol to indicate that this takes a single string argument, you can also infer that too. So there are some binaries that you're not going to get symbols for. So once you get comfortable enough doing this, you can do a lot of inference and not necessarily need all the symbols. So up at the top, like you can see that the argument, if one is not supplied, then it will just pass in the null string. And the way that these are pushed onto the stack is you can have a variable number of arguments. So for every argument, 2 arguments are pushed onto the stack. The buffer to the field that's being traced and the length of that buffer. And then at the very end, you push a null to indicate that no other arguments are being accepted. Again, in this case, there's just a single string argument. So this is just for your reference. So look at all the WPP _ SF _ these things. What you'll notice is in a lot of Windows code, you'll see, well, a lot of strings are interesting, but a lot of pointers as well. So there's opportunities to leak some potentially valuable pointers, or who knows, I mean, there's a lot of tracing in the LSA plugins, so who knows, like maybe there are some events that might dump some credentials. I actually don't know, so you could very well investigate that yourself. So I'm going to start building out a custom TMF file for that one interesting event that came up all the time in my trace. So what I supplied was the message number. So we got this in IDA. I'm supplying the event source. You can call this whatever you want. Defender made sense. You give it a line number. I don't really know what the line number was, so I just went with what was standard and stripped symbols. The message number, 14. So we got this from our trace. And then the message string and the arguments. Okay, so the %10 refers to the first argument that's passed into it. The _s indicates it's an ANSI string. And then item string refers to that string as well. So if you download these slides, I'll post them to my Twitter later, and click on that more link, you'll see where, for example, _s corresponds to item string, because that's important when you're building these out. Okay, so now when you run the trace again, you'll start to get a lot more context. And so this in and of itself is kind of interesting. So I haven't done really any reversing at this point, but now I see that the MP aggregate attribute X internal function is called all the time with these string arguments, which look like they might be like signature names from like the signature database. I don't know, but I'm supplied with so much more context at this point, so that's really nice. And then there's like a million other events that I can start building these TMF entries out for and get all kinds of like really interesting context. So that, in a nutshell, is how to recover TMF schemas. Kind of a pain. So I encourage all you out there to give this a shot. I've got a blog post that I wrote that covers in a little more explicit detail how to recover these things. I'll show that to you at the end. Let's jump into TraceLogging. Now we're still going to be using MP Engine as our target, and we're interested to know what interesting events might be present in there. So I don't know of any other tooling out there that parses the TraceLogging binary blobs, but I'm a PowerShell fanboy, so I wrote a script to do it in PowerShell. So it's called get TraceLogging metadata. So you just give the path to a binary. Really, any Windows binary at this point supports TraceLogging, and you'll see something like this. So there's a providers property, which will list out all of the supported providers in that binary. So we're going to do a trace on the Microsoft.Windows.Defender provider. There we go. All right. And then just to show you all the events, well, some binaries will be more verbose than others. The Defender AV engine is pretty verbose. So this is maybe all these event names that you see here. I don't know, is probably 5% of all the events that are actually supported in there. So very verbose stuff, just like WPP. All right, so if we wanted to do a TraceLogging trace, it's a lot easier because we already have a tool that can parse out the binary format, so we don't really have to do any reversing if we want to just start capturing events. So let's go ahead and start up a trace. So in this case, I'm just showing you an alternative. You could use logman, but you can also use the PowerShell commandlets here. It's a new ETW trace session. You give it a name, any name you want. And in this case, log file mode corresponds to the 8 corresponds to real-time mode, and the 100 corresponds to real-time mode, and the 8 corresponds to an independent trace session. So if there's another process that like crashes that does a trace, it's not going to stop your trace. And then for testing purposes, I usually set a pretty aggressive flush timer. So this will flush the ETW buffer every 1 second. This is not performant. This is just for testing purposes to get as many events into our trace as possible. So now we have to add a provider to the trace session. We have to actually trace something. So what the provider we're going to trace is the one that came up in the tool, the one that starts with 7AF8, Microsoft Windows Defender. So that's the GUID that you see there. I'm adding it to the Defender TraceLogging trace. I'm saying match any keyword, just match on anything. I don't want to do any filtering, just log all the things. Same with level FF, and don't worry about property. Well, that will log events even if the keyword specified in the code is 0. Now, this starts a real-time trace, so if we want to consume those events in real time, not using code, but using like built-in Microsoft utilities, we can use tracerpt.exe. You specify the real-time trace session name, Defender TraceLogging trace, and then instead of outputting to the raw ETL file, which really is not very useful, you can have this in real time convert all the events to an EVTX file. And then when you're done, you call remove ETW trace session. And what you'll see when you do that is the following. Okay, so this wasn't the most verbose trace, certainly not as verbose as the WPP trace was for the Defender engine, but it still caught a few things. So here is the provider name that we saw in the output of the PowerShell tool that I wrote. Now, event ID is interesting. It's worthless. So the event ID, in this case, is computed dynamically. So the event ID is, remember in the binary, in that binary blob, it has trace logging metadata if it starts with ETW0. The event ID is the file offset to the event metadata within that blob. So depending upon the version of that binary, that event ID is going to change all the time. So just be aware of that. And now, we didn't even have to build our own schema. Whatever this event corresponds to, I don't recall. I could look back in the PowerShell tool, but we have all this event data populated for us without having to reverse anything. And without having to be our own protected process. The Defender AV engine is a protected process. So I had to be admin by default to do this, but I didn't have to attach anything, which is great. Okay. All right, so some defensive use cases for trace logging. As I mentioned, currently Defender ATP is the only endpoint security consumer of trace logging events, and that's probably for good reason too. I doubt that Microsoft would ever make any sort of guarantee that those events wouldn't change, so your mileage may vary. I use these primarily for supplementing my static analysis with dynamic analysis and not having to use like crazy PPL bypasses that like Alex and James have come up with, because I'm not that smart. Okay, so there is an ETW security model behind all this, thankfully. So an arbitrary, unprivileged user, in theory, can't start a trace on the Defender AV engine, all right, in theory. So there's a default SDDL or security descriptor where if one is not specified for a trace session or an ETW provider, There's a default one that's used. So you can override that, and there's a bunch of, you'll find in the security registry key here, there's a ton of GUIDs in there with their own binary security descriptor. So just the other day, actually, I wrote some tooling to parse all those out and audit all of those, and I'll cover some of the findings that I found. But by default, one of those GUIDs in there represents the default GUID if one is not specified. So these are security settings for both trace sessions and ETW providers. So by default, only the administrator or the performance log users group and local system, local service, network service can do most trace logging things. So I underscored performance log users group because that's going to come up in a little bit. By default, there are no users in that group by default. Okay. So if you were to look at that, the default GUID, I forget what it is. I have a blog post that talks about what it is. These are the default access rights granted to the performance log users. So you can do all the following. I'm not going to go into what each one means. I'm just going to cover the ones that are particularly interesting to me as an attacker or someone who might want to subvert the overall security model. The most interesting ones to me are TraceLog GUID enable. This means I can add or remove a provider to or from a trace session. So from a tampering perspective, if I was granted access to this, and so if I was granted too much access to the event log application trace session, and I could remove the providers from there as an unprivileged user, that would be bad, okay? TraceLog create real-time and on disk permit you to start and stop a trace session. And TraceLog access real-time allows you to consume events in real-time mode. So I wrote a silly little auditing script that went through that HKLM like security key, parsed out all those binary security descriptors, and then what I did was I grouped by so I took every single ACE that was granted in all the security descriptors, and then I lumped them together by user and group. And then I went through and looked at all the unprivileged users and groups, so like the everyone group, the authenticated users group, to see if there were any GUIDs that were granted too much access. And so I found these three which stood out to me. So of the access rights that are interesting to me as an attacker, I've highlighted those four, and they all correspond to the same three GUIDs, which I thought was kind of interesting. So the next step for me was to identify, well, what do those GUIDs actually correspond to in code? And what I did was I ran my get TraceLogging metadata script over every binary on my system. And what I found was that those GUIDs correspond to mssense.exe. So this is Windows Defender ATP, the user mode service, which is a protected process. And so you see that one that starts with CB2F. That corresponds to the provider GUID for the sense events provider. So this is all the raw telemetry that is sent to the cloud with Defender AV. So that's kind of interesting. So the Defender AV service consumes a bunch of events from the kernel and also a bunch of different ETW providers. It takes all those in, and then via the cyber events provider essentially uploads all those to the cloud. So if you can tap into those are pretty interesting. Certainly if you could remove that provider from the Defender ATP trace session, that would also be really bad. So it looks like there's a misconfiguration here. So what is it that we could actually do? Well, here's our attack plan. In this case, I've determined that as an unprivileged user, the only thing that I can do with that misconfiguration is leak Defender ATP telemetry. Because I don't have permission to do anything with the Defender ATP trace session, I can't remove those providers from its trace session. So that would be really bad if I could. But at least, I can leak this telemetry and start parsing that out, and there's some pretty interesting information in there. I did report this to Microsoft. So what you would do is you just establish a trace session using one of the permitted GUIDs. Now, there's no built-in tooling that allows you to specify a GUID for a trace session, but you can do that in the APIs. So I just wrapped the APIs, and I specified that just one of those as my trace session GUID, since I'm allowed to do that. And then the other would be to add the Cyber Events ETW provider, the one that starts with CB2F, to the trace session that I just started, and then the events will start flowing. Now, I don't have an onboarded ATP endpoint on here, so I can't actually collect those events. But sure enough, it did work as an unprivileged user. So hopefully Microsoft will clean this up a little bit. I don't really consider this to be too critical, but yeah, just something that they could clean up. Now, that was cool and all, but really, in my mind, the most glaring security issue is, raise your hand if you have Visual Studio installed. Okay, quite a few people. All right, then the whole ETW security model is completely subverted. None of this stuff really matters. Now, there are some security descriptors which are pretty locked down, but by and large, there's very little you can't do in ETW from a tracing and a tampering perspective if you have Visual Studio installed. So this was reported, I reported this back in December 2008. It's an acceptable risk. When I tweeted this out, turns out James Forshaw found this as well, and I believe he used that as like an attack primitive in one of his many exploits. So yeah, so just to be clear, when you install Visual Studio, it adds the interactive group, which is like any logged on user, I believe, to the performance log users group, which is granted a lot of access by default. Okay, so some references. Again, I'll be publishing these slides online, like through my Twitter pretty soon, so you can use these as references. The first link that you see there goes into very explicit detail, more so than I've done today. And then if you want to learn about how to tamper with the event log, the second link is there too. There's some great posts on ETW trace security as well. I have a link to the PowerShell script that you can use to parse out the trace logging metadata. I supply you with my handcrafted artisanal AMSI.tmf file. So just to show you like how much work can go into recreating these TMF files, I supply that. And also I went through as many public symbols as I could, stripped out the TMF files in there if they were available, and I posted those to GitHub if you want to do some research there. All right. So thank you to everyone in the room. Particular shout out to Hugo and the Recon crew for having me. It's amazing. This is like my 6th or 7th year here, first time speaking, so I'm very grateful for everything you do. Jeff Chappelle on his ETW security post, Alex Ionescu, you're just awesome all around, and MSRC for being very responsive to my reporting. Albeit I wasn't entirely satisfied with the response, it was a quick response, so thank you. All right. And for later reference, if you want to do any of the stuff in the kernel, the methodology is like pretty much identical. So I've got that reference there as well, just slightly different APIs. So thank you. I'll open it up to questions now.
So did you find anything interesting in those logged messages after you implemented your stuff?
I'm sorry, was your question, did I find any interesting messages specifically in Defender AV?
Yes.
I haven't gone that far yet. I was just using it as a use case. Like in my link here, I rebuilt a TMF file for all supported events in AMSI. That may have changed, like they've probably added some events. Like the Defender team loves to use WPP. They trace all the things. So unfortunately, I don't have anything particularly interesting for you to reveal for Defender AV, but now you have all the tools at your disposal to find out. And again, as I mentioned before, I think it'd be really cool for someone to rebuild TMFs for all of the LSA plugins that do anything credential related. There might be a needle in the haystack there.
thanks for the talk. There we go. Hey, thanks for the talk. I was just wondering, since the general use, as you suggested, seems to be to essentially just read these logs that they're generating, to what extent would you recommend building something like, let's say, EDR tooling on top of this sort of logging that's already in Windows, rather than trying to do all sorts of hooking and unstable things that other EDR solutions try?
Sure. So my recommendation for an EDR is don't touch WPP or TraceLogging, but perhaps consume manifest-based ETW, but still your mileage may vary. I'm sure Alex has plenty of rants about this. So because there's a manifest installed, it lays out what all the events and fields and data types are supported. I'm not aware of any particular documented guarantee from Microsoft that those won't change. I have seen in some instances that like the manifest, like XML, they do maintain versions, but that's also been super inconsistent from my experience. But as an EDR vendor, just in summary, I would investigate manifest-based ETW. As an RE or an attacker, I would investigate WPP and TraceLogging. You're welcome. Okay.
More questions?
Thank you very much. Oh, Alex,
Hey.
yes.
Two quick questions. One, TraceLogging is documented, obviously third parties can use it too. Have you seen at all third-party products starting to leverage TraceLogging as well, or is it still mostly Microsoft that you see?
Personally, in my limited view, I have never seen any other third products consume WPP or TraceLogging.
And second one was, have you looked into, or do you think attackers might start going towards offensively spamming or lying or producing fake events? I mean, I guess if it's only Microsoft reading them for now, but thoughts on that?
Oh, absolutely. Yeah, I mean, the ETW security model also applies to the generation of events, so like writing to ETW providers as well. So that's absolutely a viable attack use case of just an attacker assuming they have permissions to write to arbitrary ETW providers to flood whatever trace sessions are attempting to consume those. So it's a great point, yes.
And I guess you could also do, as a non-authenticated users, do actions that might cause a flood, right? Instead of faking it, just do 10,000 virtual allocs and then...
Oh, absolutely. Yeah, that's a great point. So yeah, like you mentioned virtual alloc. So that's a specific event, both like local and remote virtual allocs, both from user mode and kernel mode are events in the threat intelligence ETW provider. So yeah, conceivably you could just spam those events by virtual allocing all over the place. So yeah, I mean, there are fixed buffers in ETW. I haven't really researched the whole like perf side of things. Alex, you probably know better in this space. And I know there's also a hard limit, which you mentioned to me a while ago, on the number of trace sessions that can be established. So maybe there's a flooding opportunity there as well to just, well, as I showed you for the Defender ATP one, authenticated users can create a bunch of those trace sessions using those using those GUIDs that were allowed. So yeah, conceivably an unprivileged user could also spam all of the trace sessions, inhibiting the ability of endpoint security products to consume events, theoretically. Good questions.
Thanks.
All right, thanks everyone.